All right, so let's start this off. Let's see if this works. Why is this not working? Either way, first thing I'm going to ask you to do, this is a free point basically, convert a exponent to a fraction, or change the exponent fraction into a radical, aka like a square root thing. So say 3 to the 10 over 7th power. Does anyone want to tell me how that becomes?
7, 3, 10.
Yeah. So you make the root, the denominator becomes inside the root, so that's a 7.
Wait, I have a question.
3 to the 10th power.
On the pocket, okay. Like number 2.
It's on the outside, but math, it's the same thing. So it can look like this.
Also, first look, you look at number 6.
Sure. Could be on the outside too.
But see, that one's negative, but it's also not, it's not an odd number. I don't know.
It's okay because it's a negative inside an odd root. So it's not imaginary.
So what is that? So what happens?
You just do -2 to the power of 4 9ths. So that's a free question. Of course, I'm going to also ask you the reverse. 7, 4th root, and I'll put the 5 over here. What does this convert into?
Yeah.
Good, 5 over 4. Make sure the full, anything in your root becomes your denominator. Like this?
Yeah.
Then it would just be, yes, 1 over 4. And then if I just had like square root 3, that would just be 1 over 2. So the divisible numbers in here is a 2. You assume is a square root if you don't see anything. And the exponent is a divisible 1. You assume it's just to the 1 power if you don't see anything.
Wait, that's one of the.
These are
One over.
technically 2 questions, one on the top, one on the bottom, right? I convert fraction to radical, I turn radical to fraction. Pretty simple. That should be 2 free easy ones. Start you off good. This one is pretty simple too. I'm going to give you, let's say, the 4th root of 32. I'm going to ask you to simplify.
1, 4.
No, this is not converting. So this is a different thing. So I need to simplify, kind of like how you simplify square roots. But because this is a 4th power, I'm going to need a pair of 4 or a set of 4 in order to leave the middle. So what I'm going to do is break this down. Okay, 2 and 16, yeah. Good, 4 and 4. 2, 2, 2, 2.
Like you put the other to the inside.
Yes. So I just want to point out, what do you have on the bottom?
4.
2, 2, 2, 2, 2. You got 5 2s in this case.
Yeah.
Because this is to the 4th power, you're going to take these 4 2s, and it's going to go on the outside. And then anything left over is going to be on the inside multiplied to itself. In this case, it's just a 2. So it's going to be 2, 4th root 2. If it was 5 on the root, you would need 5 of them. If it was 10 on the root, you would need 10 of them. It's not going to be that high, but that's basically how you simplify. It doesn't matter what number it is. Any question on simplifying a radical? Yeah, so these I have to use numbers, but the next part, the whole next section is going to be, well, most of the section is going to be variables. Let's see. What? All right. Next one is going to be exponent operations using the fractional exponents or fractional, exponents. These will all have variables because I want you concerned about what's happening to the exponents versus the, I don't know what to say, the number inside. So, yeah, I'll just explain it.
Do you go to the all of that? I get so confused with this. Do you write little rules if you're adding to the figures?
Yeah.
Look at, see, is that a separate problem?
There's gonna be a second problem, and I'll just put my third problem. That's to remind you all the steps. 2/3 to the power of 5/4. Okay. These are 3 separate problems. So this was 3.1 1 or 2. Let's check real quick. This is 3.2, but they always give you it with numbers. I don't like that. I'm going to give it to you in variables. So I want you to see this. So when you multiply exponents, you add them. But if you notice, these fractions do not have the same denominator. You need them to be the same denominator to be added. So I'm going to need to multiply the bottoms to make a match. What would the bottoms have to be? Which the goal is going to be what? 15. So I need to make it 15. So this one is going to be a 5, and this one's going to be a 3. Whatever you do to the bottom, you also do to the top. So 5 and 3. This should be in 3.2. Yeah. I think they give you all the numbers, but I prefer variables because I don't care about the number on this side. I'm talking about what's happening. So you're going to get your first fraction, which is 10 over 15. And you're going to get your second fraction, which is 12 over 15. Now you could add them up. So your final answer is x 22 over 15. Sometimes you could simplify it. Then the next one you will be able to simplify. This is because you're multiplying them. What you're physically doing to the fractions is adding them. So because you're adding fractions, you need a common denominator. Yeah, find a common denominator. Oops, I just want to make sure everyone got the first one. It's the second one. When you're dividing, you're going to subtract. These already have the same denominators. So 10 over 3 minus 7 over 3 is result to 3 over 3. What's 3 over 3 simplified? Just 1. So your answer is going to be just x. If you wrote x to the 1, you'd be totally fine also. But it's not necessary. Yeah. So dividing will mean subtract the exponent. Same thing. If you had a different denominator, you have to find a common denominator. Is it x over x? No, it's just x. X to the 1. Yeah. It's like in the previous ones, you combine it to one variable. This one, when you have an exponent to exponent, you multiply the fractions. When you multiply fractions, though, no need to change the denominator or anything. You just multiply straight through. So 3 times 4, 2 times 5. Numerator to numerator, denominator to denominator. So that's 10 over 12. Can we simplify 10 over 12?
Yeah.
5 and 6. I can take out a 2 from the top and bottom, 5 to 6. So my final answer, x 5 over 6. You just multiply them straight through. So these are the ones with the variables. And now you're going to see the ones with the numbers will require some other things. Okay.
Wait, what's the logic? Is it the same base?
You'll see what I'm going to show you. That's the next step.
Can you write that down?
Sure. Let me exhibit the rule first, and then I'll write that down if you want to after. All right. 3 third root 10 plus 6 third root 10. Okay. Not even converted. These have the same base. So kind of like same terms, just like a variable. If they have the same terms, you can add them. So 3 plus 6 is going to result in 9 cube root 10. You do not add the thing on the inside, you only add the things on the outside. You could think of it as like a variable, kind of like the basis, if you want to think about that. They have to have the same exact base. So they're both to the cube and they both have a 10 inside. Okay. Yes. If it doesn't match, then you can't combine them and you just stop.
Is there any of that? How you can do it?
I'm going to show you what you need to do before you could do it. So let me set up one.
Or you doesn't know what type of solve.
No, I'll show you one that you need to do work before you can solve it. Let's let's do 8 plus 4 square root 9 goes to 18. Yeah. Okay. Now I did just tell you, wait a second, these don't match, Mr. Tolman.
I guess you do.
What do you think we did? Go ahead.
You break up 18 first, and then there's the 18 inside, and then you kind of, well, first you bring like whatever's the outside.
You got the right process. So right now our bases don't match. Doesn't necessarily mean we're completely over. If it matched at the beginning, we would just combine them and we say
But if you want to like shoot the whatever, then you can do it.
you couldn't do it, or yeah, you couldn't do it at all. But what you're going to do is break it down. So we're going to break down both of these. So this is like one of the more involved questions, because before I told you just to simplify. Now you're simplifying and combining and rationalizing. Yeah, so let's first reduce these square roots. So I'm going to simplify these square roots. On the left side, for the 8, I have 3 2s. This is a square root, so I only need a pair of 2s to escape. That's going to go on the outside. And any leftover 2s is going to stay on the inside. When it escapes, it's going to multiply what's in front. So 10 times 2, it's going to be 20 roots, and anything left over, which happens to be 2. On the right side, it's going to be the same thing. I have a pair of 3s this time, so that gets to escape. And I have a leftover 2. So the 3 times 2, 12 on the outside, square root 2. So sometimes we need to simplify the root before we can add. In this case, we simplify the roots. Hey, wait a second. Lo and behold, they became the same. 12 plus 20, 32 root 2. If I were going to put a problem and they didn't match, that'd be kind of like a waste of your time, wouldn't it be? So you can kind of infer they should match on the test. I can't put a lot of problems here because we have so much stuff. So I want to put a fake one if that's what you're asking, kind of like that. One more from this set. I'll just scroll down so I don't have to switch pages. This is a little bit more straightforward. 3 roots 10 times to 4 roots 6. I'm not going to be dividing on the root test. None of the square root is. The only dividing you should be doing is the exponent one, which is where you're subtracting, basically. So for this one, the fronts are going to multiply to each other. So that's 12. It has to be the same roots. But I'm not going to trick you. It'll be the same root, but it has to be the same type of root. And then you're going to multiply the insides. 6 times 10, 60. They're still both square roots. These are the roots. Yeah. So, because the instructions for this set would say simplify, we're not necessarily done simplifying. Again, we're going to have to break this down to see if we can simplify it. 6, 10. By the way, you already know 2 factors because you just multiplied to it. 5, 2. 3, 2. So I have a pair of 2s. So I have a pair of 2s, so that's going to get to leave. You multiply them. And then the insides, which is a 3 and a 5 left over, are going to multiply on the inside. Outside multiplies, inside multiplies, same concept. So 2 times 20, 12. I almost said it. 2 times 12 is 24. Square root, You only have a 3 and 5 left, so 3 times 5, 15. This is your final answer. You won't get full credit if you get to here. You need to get to here, okay? Any question on that before I go on to what will be the next section? I will post this recording later for you too, Sam. Okay. All right. Our next one is going to be function operations and notation. So let's say I'll give you a f of x is 3x plus 2. I'll tell you g of x is x squared plus 1 or something. I'll say h of x is 5x minus 4. Something like that. So here's a different type of problems you could have. I have to give you this, of course. But if I say something like, tell me what g of 3 is. Anyone knows what I would do? Go ahead, Jasmine. Good, 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 excellent. Any x I see in that equation will become a 3 now. Any x I see becomes the 3 in the g of x equation. I don't care about f of x or h of x. I didn't mention them. Only g of x. So 3 squared plus 1, your end result should be 10. Shana. Understood? Okay. So we have that. You could have f plus h of x. What are we going to do with that, Jasmine? Uh-huh. Perfect. So when I say f plus h, I could also say f minus h, f times h. I don't think I will do divide for you, so even though that is possible. But whenever operation I do, I'm going to do to both equations. Because it's x, it stays x. So in this case, it's going to be 3x plus 2 plus 5x minus 4. So the f of x is here, and the h of x is here. After that, all I'm doing is combining like terms. 3 plus 5 is 8x. 2 plus negative 4 minus 2. Of course, if you were subtracting, make sure you distribute the negative properly, okay? If you were subtracting, make sure you distribute the negative properly. Jana? This x? This x tells me that the x stays at x. If it was any other number, I'll do an example, it would turn it to that number. So this x is important in the sense that it's going to stay an x. It doesn't have a job. It's just, its job is like to change nothing. Don't get, that is the wrong idea. This is function notation, so you have to think of it differently than your typical multiplication, okay? You got to know this is a different notation, okay? Which means it has different ways to read it. G H of X. So if G and H are next to each other, what are we applying? We're doing? Good. We're going to multiply this. So first I would write both of them though. X squared plus 1. Yes. Good question. I just want to reiterate for the recording. So if I put a 2 here, every X would become a 2, which means you don't even have to FOIL. You would just do the math and then multiply. So when it's a number, it's actually a little bit easier. I'll do that next, just to practice that. 5x minus 4. Now, but we're multiplying with x's, so we can't simplify first before multiplying, so we're forced to FOIL. 5x to the third minus 4x squared plus 5x minus 4. And then you just look a quick through. Can I combine in like terms? In this case, no, all of them are different. Box it, we are good. F minus G. Let's put 2. So iterate on what Ellie said. If you have a number, every x becomes said number. You could solve it in a number and then put it after. I think most people find it easier, so I'm going to put the number in right away. So 3 times 2 plus 2 minus, let me put that in a big parenthesis. This is G, right? So it's going to be 2 squared plus 1. So notice how every x became a 2 in this case. That's what the number in front does, okay? So 6 plus 2, my first number is 8, minus squared is 4, plus 1 is 3, or plus 4, 1 is 5. So 8 minus 5, which results into a 3. The last 2 types from the set is going to be composite functions, which is a function in a function. Let's do f of g of x, and then we'll do one with a number next. For SAT purposes, you might see it like this, FOG. This is the same thing, by the way. That's what I have below it. I don't know if the SAT do it this way or this way, so I'll show you both, but
No,
I will show you in.
that way.
Is that though? All right, perfect. Then. That's inverse, so we'll get to that.
Not all.
Yeah, but it's very easy, no?
Wait, so is it 3 times x squared plus 1?
So first off, I'm going to replace the g of x with the actual equation g of x is. Which you might be right, I just got to focus. So this g of x is going to become f of, I'll do it in green to represent I'm changing it, x squared plus 1. The g of x has become x squared plus 1 because they're equal to each other. So there's nothing wrong with that. After that, every x squared plus 1 is going to replace every x in the f equation because the f is now on the outside. So 3, this x is becoming x squared plus 1 plus 2. A lot of people forget that plus 2 at the end. I know. If it works, I don't mind it. So then let's just do a little bit of math. Distribute 3x squared plus 3 plus 2. Combine some like terms. 3x squared plus 5. We could also have one with a number. So I'll just do like h of f of 2.
Wait, so is it just that for the f part, the x squared here? Because the h.
Well, at first you're going to put 2 for the f part. So h of, now I'm going to plug in 2 for the f part, which is 3 times 2 plus 2. So in the f equation, I plugged in a 2. Then I'm going to just solve it. 3 times 2 is 6 plus 2, h of 8. So now we have converted, now we're on a new set. Now we're looking at h and we're going to plug it in 8 into the h. Which, what was the h equation? 5x minus 4. So 5 times 8 minus 4. 40 minus 4. Final result, 36. I'll tell you, you do it right. If your x is in the function, you should have an x in the final answer. If you have a number in your function, you should have just a number in your final answer. Any questions on that? There's a lot. We still have tomorrow to also study. At least there's class, and then you have whatever time you have in time. What is next? Inverses? Yeah. Okay, inverses. Y equals 3x minus 10. I'm going to do 2 inverses. Let's do y equals s squared plus 2.
So this is when you switch to
Let everyone copy that. Inverse, yes. Yeah, Jasmine, you want to answer? Or?
Yeah.
No, let me just say it out loud for everyone. But good job. All right, so for these, you simply got to do this. First, you need to swap your x and y. So x equals 3y minus 10. After you swap the x and y, you put it in a weird situation, so you got to get y by itself again. This is just basic algebraic skills, which is I'm trying to get y by itself or isolate the y. So plus 10 first. So x plus 10 equals 3y. Then I'm going to divide 3 on both sides. When you divide to both sides, remember everything needs to be divided. If you multiply to both sides, everything will need to be multiplied. You could think of it as a type of distribution. So x plus 10 over 3 equals y. Once your y is alone, you're done. What do you mean x on outside?
Like it's like x and then it's like 10 over 3.
No, x has to be on top of a 3. That's very important. You could technically write it as x over 3 plus 10 over 3, but that seems a little bit more cumbersome. So I would rather you write it like this. Or I suggest you write it like this. I think that's better. Okay. For the second one, again, same process. We're going to swap the x and y. That means that y is going to get nestled right underneath the squared. Minus 2 on both sides. X minus 2 equals y squared. Good. You need to know because I have a squared, I have to square root both sides. If I had a cube, you would need a cube root both sides. If you had a 10th power, you need a 10th root at both sides. It has to match. This one you have plus or minus, but I'm not going to put right or wrong if you don't put plus or minus. Because technically that stops it from being a function, but that's like, I don't really care. Inverses, I think, are pretty straightforward, but I'll take any questions.
Like that's it. It's not gonna be so much harder than that.
No, I mean, I'm literally looking at the test and I'm just making questions almost the same numbers, just changing numbers. Anyone know how much time we got left? In a minute. So I'll cut it off from here so I don't have to stop weirdly. Tomorrow we'll go over our graphing. So bring your graphing calculators if you want to help yourself with that. And then we'll go solving equations, okay?
I will.
No
Thank you.
problem.
Well,
No problem, no problem.
Yeah, I'll